Hello, physics, advanced physics question and answer, M PT2E. The question is question number 13. The current in a non-linear resistor is I is equal to 0.05 V raised to power 3. V is the potential difference across the resistor, and the resistors is connected in series to fix resistor. This resistor, nonlinear resistor, is connected to in series with the fixed resistor, and the battery of 9 volt is connected. What value of the resistance of the fixed resistor have to so that the current is 0.40 amp flowing through the circuit? So this is the diagram. So 9 volt battery. 9 volt battery is applied, and this is 0.4 amp is the current flowing into this is the resistors, which is a non-linear resistor. This is a linear resistor, which linear resistor obeys Ohm's law. This is obey Ohm's law. So this is the voltage. The voltage is equal to voltage applied. This is a voltage on the V1 on the V2. V1 V2 is equal to 9, and on the first one is I is equal to 0.045 V1 raised power 3, which is this one. This is the non-linearity. So V1 is equal to voltage cube is equal to this one. So this is equal to 8. So V1 is equal to 2 volt. If it's a 2 volt, this is a 7 volt. So 2 plus V2 is equal to 9 volt. So V2 is a 7 volt. So V is equal to IR on the linear one. R is equal to V2 over I. So V is 7, I is 0.4 amp, 7 volts. So amp. So this is has a resistance of 17.5 ohms. So this is R. This is the answer. Second, this is a slightly complicated and long question. So this is the general formula of a pendulum. For the time period P is given. 2 pi I is the moment of inertia, G and mass, and L is the mass, M is the total mass, LCM is effective length of the pendulum pivot to the center of mass, and I is the moment of inertia, mr square generally, and for the uniform rod is 1 over third mr square because of the symmetry. So question 1 is identify LCM and I for a ideal pendulum and the length of L and M of the mass when L mass is given. Repeat the experiment the same. Repeat the option A for a uniform rod, and the C is for a real pendulum instead of ideal pendulum with the mass of the object MB attached to the pivot using uniform rod of mass MR and the length L, and find the period. D, most substance expands. This is a very important question. What temperature change can the clock tolerate if it is to remain accurate 1 second in 24 hours? And the clock is made of brass. Brass has a linear expansion coefficient, which is 19 into 10 to the power minus 6 Kelvin in raised power 1 minus 1. Repeat the calculation with another metal which has alpha, which is lower, 1.2 into 10 power minus 6 or Kelvin raised power minus 1. So for first part, which is that L is equal to MCM is equal to L, and I is equal to ML square. So if you substitute the value, so this will give you this L over G, which is a simple pendulum. For uniform rod, LCM, which is L by 2, and I is equal to 1 by third ml square. If we substitute this value, which is equal to 2L over 3G, so this is the length, and this is the mass, and this in this one is the whole length is a pendulum. Number C, actually A and B. So LCM is a combination of this one. So also the pendulum and also this one. L LCM is L into MB plus half MR. MR is this one is bob and rod. So MB plus MR, and the moment of inertia is MBL square plus 1 by 3 MRL square. If you substitute these values, so in this original formula, so this will be the first this one. So this one comes here, and G into M. So M will come like this one because it's the combined of those both of them, and then LC. LC is this one. MP. MBL squared LC. MBL no square by L by 2 MR over this one. This formula. This formula is here. And if you simplify this one, we will get for the ideal MR is equal to 0. So if we MR is equal to 0, this is 0, this is 0, this will be cancelled. So we will get L over G, which is the simple pendulum. If MB is equal to 0, this is 0, this is 0, MR cancel, this is equal to 2L over 3G, which is we have the rod. Now this other thing is this is the simple pendulum, the clock 2 pi L over G. L is expansion. It is expanded if the temperature is the change. So L this one L naught L dash is equal to L naught into L this one. So this will be equal to this is L dash the change in the variation which will be with the temperature and without any steady. So L plus L naught into this one delta alpha into delta t minus this one. So this is P dash and this is P. 2 pi L over G is a is a common if you take this common. So this term, so this will be L is a common. You can take this one. So this one will be 1 plus alpha delta T minus 1. So this is equal to P. So if it is come to down, so that is P. So P is the P value is 1 second over 24 hour. So this one. So uh, so the P is also cancelled. So this will only depend upon the is alpha. If alpha is 19 in 10 to the power minus 6 Kelvin, so if you substitute this value, so this one will be, this value is equal to this one. So this is because of this one is a square minus 1. So this will give me alpha delta t. The t we have to find delta t, which is 1.22 Kelvin. So if you substitute alpha here, which is difference coefficient of expansion coefficient, then delta T is 19.3 Kelvin. So that means the metal with higher expansion coefficient of expansion is better for the clock.